Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, minimum deletions to make string k special. And we'll also be discussing one harder follow-up to this problem, wherein the word will not only consist of lowercase English letters, but we'll assume there are 10 power 5 possible letters, and word can consist of any of those 10 power 5 characters, right? So if you're here just for the follow-up question, all the timestamps are there in the description down below. You can move to the section which you are interested in. Having said that, I would encourage you to watch the complete video to get a better understanding of how to approach this kind of problems in general. So with that, let's get started. The problem states that you are given a string word and an integer k. The word would be k special if this condition holds for every indexes I and j. We have to return the minimum number of characters we need to delete to make this word k special. So we have this particular word AAB, CABA, and k is 0. It means for every two indexes here, this criteria should be satisfied. And what is the criteria? Criteria is frequency of that particular character in index I minus frequency of the character at index j. If you find the modulus between them, that should be less than equals to k. So here k is 0, so it means this entire thing should be less than equals to 0, which in turn means entire thing would be equals to 0, which if you solve further, it will come out to be frequency of word of I should be equals to frequency of word of j in this particular criteria. That is, for every character, the frequencies of them should be equal. So one of the way to achieve it is delete these two a and delete this c. If you do this, you have done 3 deletions, and after 3 deletions you have 2 b's and 2 a's, which basically says the frequency of every 2 character is equal. So you can try out any other possible sequence of deletions. You will not be able to make the string k special in less than 3 deletions, and hence the answer here is 3. So let's take one last example. Let's say this is a string k is 2. We need to make the string 2 special. So one of the way to do that is you simply delete d and a from the word, and whatever string is remaining will be 2 special. How? Take any two indexes from here, and the difference between their frequencies will be less than equals to 2 always, right? So let's see, we have b, c, d, 3 characters here, and if you see, frequency of b is 2, frequency of b is 2, frequency of d, if you see, is 4, 1, 2, 3 and 4. Notice you have deleted this d, so we will not count this. And frequency of c is 3, so 1c, 2c and 3c. Now if you figure out the differences between any two characters here, that will be less than equals to 2, and hence the given string is a 2 special string. So in 2 deletions we are able to make this. You can try out any other combination. You will not be able to make this 2 special in less than 2 deletion, and hence the answer here is 2. So hope the problem statement is clear. Now how to solve this? One of the brute force solution to solve this could be try out every possible sequence of deletions. So you have this particular string of length n, let's assume. You will try out every possible sequence of deletion. So how many sequence of deletions could be there? 2 power n. Every character may or may not be deleted. So total 2 power n sequences are there. For each of those 2 power n sequences, you will figure out whether after deleting those sequences the string is k special or not. And if it is k special, you will just see how many deletions you have to make for that, and the minimum one would be your answer, right? So to implement this, you have to first figure out or iterate over all the sequences of deletions. So as we have said, there are 2 power n number of sequences, which is very huge because the value of n in this particular criteria is 10 power 5. So that solution will surely not work. So we have to optimize this. Now what should be the first step toward optimization? So notice the inequality. Can you work with this inequality efficiently? The answer is no, because anytime you delete a character, this inequality will change for all the characters, right? So you have to re-verify this inequality for all pair of characters again. So the first task that we'll have is see if we can make sense, or if we can reduce this inequality to a more concrete mathematical inequality, which doesn't change on deleting every character every time, right? So our task is to reduce this inequality such that if we delete a character, we exactly know which thing has changed, so that we don't need to iterate over everything again, right? So let's say this is the given string word for now, and this is the frequency of every character here, because we have to figure out the frequencies. So we have computed that already. So A occurs 5 times, C occurs 2 times, D occurs 2 times, and so on and so forth. So notice, what does word of I contain? Word of I contain one of these 5 characters, right? Similarly, word of J contain one of these 5 characters. So instead of figuring out this inequality for every pair of indices in the original string, why not why not figure out this inequality for every character? Number of characters will surely be less than number of indices in the string, right? Because we are given that the word can consist of lowercase English letter. So why not solve this inequality for every character, and if that is satisfied, this will implicitly be satisfied, right? So we can simply reduce the inequality, we can simply reduce this inequality to something like this: frequency of C of I minus frequency of C of J should be less than equals to K, where C of I is a character, C of J is a character, and we know there are total 26 different C of I's and C of J's, right? So instead of this, we will now work with this, right? So we have simplified this a bit, but even now, if you delete a character, this will change this may affect all the characters again. So can you simplify this even further? So notice, frequency of C of I is nothing but one of the values here. Similarly, frequency of C of J is nothing but one of the values here. So we can say the problem is now any two value here should not be greater than K, right? So how to approach this problem now? So I would strongly encourage you to pause and try to think by yourself. So let's sort the array first, because the order doesn't matter, right? So if you sort the array, and you need to make sure difference between every two value is less than equals to K, isn't this sufficient to make sure that the difference between the first and the last value is less than equals to K? Because if that is less than equals to K, any other pair you take will surely be less than equals to K. So now, instead of solving the inequality frequency of C of I minus frequency of C of J less than equals to K, we will simply solve the inequality frequency of max minus frequency of min should be less than equals to K, right? So instead of this, we will now work with this. So now this is way straightforward than the original inequality, because if you change the frequency of any character, or let's say the frequency of minimum character, you exactly know what has changed, and you don't need to iterate over every other character again, right? So this is our new inequality. So if you haven't reached this point during the contest or while up solving, strongly encourage you to pause and try to move forward from here by yourself. So now we need to make sure difference between the smallest and the largest is less than equals to K, right? And for this problem, let's assume K is 1, right? So what is the current difference? Current difference is 5 minus 2, which is 3. We need to reduce this 3 to 1. And what are the operations we have? The operation is we can delete any character from here, right? That's the operation you have. So what does deletion would do? So let's say you delete a character from here. So what will happen? The frequency of that character will be reduced by 1, right? So if you delete a character from here, one of these values will be reduced by 1. Do you want to reduce any random value, or do you want to reduce the value for min and max? The answer is value for min and max, because that's what matters. Anything in between doesn't matter. So we will always try to reduce the value for min or max and and try to minimize the gap between them, right? So if you reduce this 5 to 4, In other words, you have said that whichever character has a frequency of 5, I just removed that one character, right? So that's possible. So you can reduce the, if you do this, the difference will decrease eventually, right? If you do this, difference will decrease eventually, and that's what your goal. So one of the possible operation that you have is decrease the largest value by 1. Second possible operation could be decrease the smallest value by 1. That is another possible operation. But if you do this, the difference will increase further. You want to make sure that the min minus max is less than or equals to k. If you reduce the max, this will reduce and the overall difference will reduce. But if you reduce min, the overall difference will increase, right? So does it mean that only operation you have is decreasing the largest value? The answer is no, because if you decrease it even further, this will become 0. And if it becomes 0, you don't need to consider this character at all. So you can simply assume that this is not there and your new min will now be increased, right? So overall your target is to decrease this entire thing. So one way could be decrease this, and second way we saw is remove the minimum value completely. In that case, this frequency of min will change and it will change to something greater, either greater or equal, right? So there are two different operations that we have. One, decrease the largest value. Second, remove the smallest value altogether. That is, you have to perform two operations here to remove this altogether, right? So with this two operation, we now need to understand how many decrease we do and how many removes we do to get to a optimal state where the number of operations is minimized and the difference is also less than or equals to k. So let's see. So in this case, you might say that okay, if I decrement this, I will require one operation, and with this one operation, I will be able to make this 5 as 4, and this entire thing, the difference between the entire thing is now reduced by 1, right? So minimum is 2 and maximum is 4, so difference is reduced by 1. Previously it was 3, now it is 2. That's true. And if you remove this, you require two operations and the difference will still be the same. So in this particular case, you might think that okay, it is optimal to reduce this one because that requires minimum number of operations. But this is not always optimal. What if they both require equal number of operations? Let's say there was a 1 as well. Let's say there was a character f. That character f has a frequency of 1, so you will have one here. Now if you have 1 here, to reduce this or to remove this, you will require one operation, and to reduce this, you will require one operation. And in both the cases, the difference is reduced by 1. So what operation will you perform? So because there is no clear answer to you to which operation to perform, because if you reduce this, you will be exposed with a 4, and if you remove this, you will be exposed with a 2. Now it may happen that whatever you are exposed with is actually better than the one exposed by other. So one simple example could be, let's assume you have this particular array 1 4 4 5. Now in this case, to reduce this, you require one operation, and to reduce this as well, you require one operation. Now if you reduce this, or let's assume that this is 3, just for better understanding, this is 3, right? Now if you reduce this to 4, you will have a difference of 4. Like if you reduce it to 4, the difference between the minimum and maximum is 3. If you reduce this instead, the difference between the minimum and maximum will straight be 1, right? So in this case, even though both has equal number of operations required to reduce the overall value by 1, one of the operation was more better than the other, and because you can't answer which one is better because it depends on what is exposed, it may happen that it is not exposed immediately. There is one more thing which you need to remove, and that's where this larger thing will get exposed. So because whenever this thing comes that which one to pick, it's always wise to try out every possible combination first and see if you can optimize from there, right? So in this particular scenario, we are stuck that we don't have a clear answer in case of ties. At least it may happen that even if it is not tie, we not have clear answer, but at least in case of tie, we can see clearly we don't have a clear answer for. So let's think of trying out every possible combination. So what are the possible choices? Possible choices is you will reduce or you will remove some of the things from the beginning. So some of the things will be removed from the beginning, and then some of the things will be reduced from the end as well. So after performing all the operations, you will have a L and you will have a R. That is, you will say the frequency of every character will be greater than equals to L and frequency of every character will be less than equals to R. And once you have fixed this L and R, you can see what all how many operations are required for this particular L and R. You can try and figure out the number of operations for every possible L and R, and the one which give the minimum operation will be your answer, right? So let's take one small example before we look at the pseudocode. So assume that L is 3 and R is 4, right? So in this case, you are saying that after you perform all the operations, the minimum you have will be 3 and the maximum you have will be 4, right? So how many operations are required to achieve this state? Let's see, you have 2 here, so 2 is less than 3. So if you have a minimum, if you want to have a minimum of 3, you need to completely remove 2. So you have to do 2 operations here. Now this character is also 2. So again, minimum was 3. If you want to have 3 as the minimum, you have to completely remove this 2 as well. So you have performed 4 operations in total. Again 2, you have to completely remove it if you want 3 as the minimum. So number of operations you have performed is now 6. Now you have 3. So 3 is okay because minimum is what we want. It is between 3 and 4. 3 is okay. Now 5. So 5 is greater than 4. So if you want 4 to be minimum, you have to reduce this to 4 as well, right? You will not reduce it to even further because you will not say that 5 will be reduced to 3 because that will waste operation. You can simply stop at R and that should be okay for this particular state. So you have to convert this 5 to 4 and that will require 1 operation. So in total now you have performed 7 operations. So in 7 operation, you are able to attain this state L equals to 3 and R equals to 4. In the same fashion, you will figure out the number of operations for every possible L and R, and the one with the minimum operation will be your answer, right? So what will be the pseudocode for this? Pseudocode would simply look like this. You will try out every possible L and R, right? And notice that this you can optimize slightly by instead of trying out any random R, you only care about the scenarios where L and R is the difference between them is less than equals to k. So you can simply iterate from L to L plus k. Now for each L and R, you can figure out the cost or the number of operations and just take the minimum across all of the possible L and R's. Now how to figure out the number of operations required? You will simply iterate over all the characters that you have. For each character, if it is less than L, that means you want to remove it completely. So if you want to remove it completely, you need sorry, not this one. I think if you want to remove it completely, you need exactly these many operations, right? And if you want to, if it is greater than R, then you want to reduce this to R itself, and that will require you this many number of operations, right? So once you have figured out these two things, you can now take the minimum across all of them, and that will give you the final result. So what is the overall time complexity of this? Overall time complexity would be order n, because L can go up to from 0 to 10 power 5, where 10 power 5 is the length of the original string. The number of characters you have at max is 10 power 5, and hence you can go to 10 power 5 from L. That is, you can say the minimum frequency of any character that I want is 10 power 5, right? That's possible. So what is R? R can go from L to L plus K. So at max K, order nk, and inside that what we are doing, we are iterating over every character. So we are total 26 characters in the beginning. So the complexity is order n into k into c. So this will also not pass because the value of n is 10 power 5, value of k also is 10 power 5, and this is fine. So we have to reduce this further. So this is fine, this can work for the given problem. We need to reduce one of these two things. So either we have to reduce this L or we have to reduce this particular loop, right? So if you have understood everything from until now, optimizing here to the actual solution is very straightforward. You can simply remove this for loop completely. How? Pause and think. So notice, why do you want to try every possible R for L? We want number of operations to be minimum possible, right? So if we let's say there is an L, there is an R, and there is an R plus 1, right? So number of operations required to make everything between L to R will always be greater than equal to number of operations required to make everything in between L to R plus 1. Why? Because what you are doing, the minimum point is L. So this will contribute the exact same thing that it would have contributed. Now only thing that will change is you will now add some operation for the characters which have the frequency greater than R itself, and in the second scenario you will add some operation for the characters which have frequency greater than R plus 1. So notice, you are now skipping, in the second scenario you are skipping the characters which have frequency of R because those doesn't need to be changed. So that's the first thing, you are skipping some characters, so you are saving on some operation. Second, let's say there is a character which has a frequency of X. So you need to make this X to R in the first scenario when you want everything to be in between L and R, and you want to make this to X to R plus 1 in the second scenario when you want everything in between L to R plus 1. So this operation, this number of operation will surely be less than what you will have in this conversion. Why? Because you will convert X to X minus 1, X minus 2, X minus 3, dot dot dot. You will first get R plus 1 and then you will get R. So you will spend one extra operation if you want to go from X to R, rather if you want to go from X to R plus 1, right? So because of that one extra operation that you are spending, everything you are spending is extra in case of L to R, and hence the value you will get from L to R plus 1 will surely be less than equal to, it may be equal as well, less than equals to the value between L and R, right? So because of this constraint, if you have, let's say, L is 3 and let's say K is 4, or let's say K is 3 as well. So do you want to try R equals to 3, 4, 5, 6, or do you only want to try R equals to 6? The answer is only R equal to 6 because we know that any of these are, the value, number of operations you will get will be greater than equal to what you will get with this R. So why even trying with each of these R? Let's just try with this one and get done with it, right? So this entire loop you can remove and you can simply say I will try out only one R, which is L plus K itself, right? And for this you can do the exact same thing and you will get the answer. So overall you have removed this K altogether from your complexity, and the complexity now is order 26 into n, which will pass the given time constraint very easily, right? So I'm not showing Pseudo the exact code. Code is very straightforward. We just have to implement this loop and that's it. Now comes the interesting part of the video, which is notice the solution is 26 into n. So number of characters is there in the solution. So let's assume that number of characters can also be 10 power 5. Like assume there's an arbitrary language where there are 10 power 5 arbitrary characters, and you are given that the word in that language, so there can be 10 power 5 distinct characters. So in that case, this frequency array that you have built this will be of size 10 power 5, and to actually figure out how many operations are required for a particular L and R, you need 10 power 5, you need to iterate over all the 10 power 5 characters to get the number of operations. So the complexity of C into N, where C is the number of character, will not pass now, right? So how to optimize this is the question. So this is now the question. If you do the exact same algorithm, this will be 10 power 5, and this entire thing will turns out to be order 10 power 5 into N, which surely will not pass, right? So we have to optimize this. Now, how will you optimize this? I would encourage you to pause and try to give this problem a try by yourself first. So again, we have to remove one of these for sure. Both are of same orders. We have to remove one of these for sure. So removing L and R means you are changing your core approach itself, right? So let's see if you can remove this CH first. If you can remove this CH first, then everything is done. If you can't remove, we'll go back to the previous one and see if and try out different approach altogether, where we don't have L and R. We'll see some observations and how to approach it from the scratch. So what this loop is doing? This loop is doing two things. One, if the frequency is less than L, it is doing, sorry, this L minus is not there. This is doing cost plus equals frequency of CH. If it is greater than R, it is doing cost plus equal R minus frequency of CH. So let's break this loop into two parts. One, this part, and let's see if we can solve this part in order 1 time or order log n time, or something which is less than order n, that is iterating over every character, right? And then we will do the exact same thing for this as well, right? So let's figure out this. So we have to now somehow remove this part from the equation and see if we can do that. So what it is doing, it is figuring out for every character that is less than L, it is adding the frequency of that character to the result, right? So if let's say L is 3, how many or what will be the total cost it will be adding? It will be adding 1 plus 2 plus 2, that is in total it will be adding 5, right? If L is, let's say, 4, assume L is 4, so how many things it will be adding? Everything is less than 4, which is 1 plus 2 plus 2 plus 3, which in turn is 8, right? So can you see a pattern here? Basically you just do binary search for L, figure out the index, right? And once you figure out the index, what you need is a simple prefix sum, right? So this entire sum you can simply do with the prefix sum. You can maintain a sum from 0 to I, and this entire thing will be there. So we can remove this entire loop with a simple prefix sum and binary search for L, and then do the to figure out the I, and once you figure out the I, just do a prefix sum of I, and that will give you this particular thing. Now let's focus on the second loop as well. So if you look at the second loop, let's forget about this now because we have taken care of this. So the only thing that is there inside this loop is now, if frequency of CH is greater than R, then you are doing something, which in turn means that, okay, if let's say, again let's take an example, let's assume that R is this. So in that case, everything which is greater than R, you will add something to your result. So you will add something for these two characters. So for this character, what you will adding? You will be adding it will be frequency of CH minus R, not R minus CH. That was my fault. So let's add modulus here as well. Frequency of R minus CH. So in this case, R is 2. So what you will add? You will add 3 minus 2 plus you will add 5 minus 2 as well, right? So can you add this entire thing efficiently? Again, exact same process. Notice what you have is, you have some sum and then you have some number of times. So if you know the sum of this entire thing, let's say the sum is B. If the sum is P, you will simply subtract r cross the count of the element, and that will give you this entire sum that you want, right? So just to reiterate, what we will do now is we want to figure out the sum of this efficiently and also know how many of these are there. So this can also be done in the binary search. You can simply do a binary search for r, get an index. Let's say r was 2, so you will get an index. Let's say this I. You can figure out the prefix sum. You can figure out the sum of I to n using prefix sum, right? So you got this p efficiently in just order one time, and you can also figure out how many indexes are there by simply doing n minus I. So you will also get this cnt, and r you already know. So this entire thing you can do in just order one time, right? So let's look at the pseudo code. So okay, just before that, so we have removed this entire loop altogether. We have removed this as well, we have removed this as well, and both of this we can do in simple order one operation by p-computing the prefix sum with us. So in total, we have removed this loop altogether, and the complexity is now simply order n, right? So let's look at the pseudo code. The pseudo code will be very straightforward. We will simply do a binary search for L index. We will simply do a binary search for the R index. For L index, this will not be there. So you will simply add prefix of L index to your result for the first criteria. For the second criteria, you will figure out the sum of everything after R, right? And you will subtract n minus r of index cross r. Again, this will be modulus because this should be plus and this should be minus, right? So okay, I think this is correct. This one is correct, the other one was wrong. Yeah, so you simply figure out the sum and you subtract n minus r index cross r, so number of elements multiplied by r. So once you figure out the cost, you will simply take the min across all the cost, and that will be your answer, right? So again, this is very straightforward. I am not showing you the code for this. Okay, so this is not sorry, the complexity was not n, in the other it was n log n, because you are doing a binary search as well, right? Now what I say, you can reduce this as well to order n by using 2 pointers. How? That is an exercise for you. Just try to see if you can optimize this entire thing by using 2 pointers, because notice you already have an L here, right? So you can maintain which index this L is pointing to, and whenever this L is increased, this L index will also increase. So because they both are directly proportional, you can use 2 pointer to maintain this L index. So you don't need this binary search. In the same fashion, for this R index as well, you can maintain 2 pointer and you don't need this binary search as well, right? So that will be an exercise for you. You can try this, get this accepted in the same question, and to understand whether your solution was correct or not. If you want me to verify or are facing any issues while submission, feel free to post that in the comment section below. I would be happy to answer. So with that, if you have any doubts, as always, comment sections are open. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.